Okay, so good afternoon. So over here we are in the afternoon, 3 p.m. and I believe that hopefully we have also participants from other region. So good day for all of you. Welcome back to RoboCup at Home Education. And for this, today we have this online classroom series, the invited lecture series. Okay, but today is a bit special because we are starting a new online challenge 2020 special series. Okay, so we invite teams from our previous online challenge to share their experience and also technical development so that can give some inspiration and also motivation for new teams to join our event after this. Okay, so today as a first, we have invited these teams, which is the gray area from Macau Puiching Middle School for with us for today, the first invited lecture series that focus on online sharing section from the participant of the previous online challenge 2020. Right. Okay. So let me start with the introduction. Okay, so first thing is today I will be the host again. So I'm Jeffrey from RoboCup at Home Education, and our speaker today is we have a few speakers today, and they are from the gray area from Macau Puiching Middle School. Okay, so this is a new series in our invited lecture series. We are very happy to invite our award-winning team. Right. So the time, so we base this time based on the convenience of the teams. So we set it to today. So it will last about 2 hours, including some interviews, some questions, some presentation, and also hopefully we can see some very interesting demo. Right. So if you need more information about this series, you can head to our website. So the link is over there. And later on, this on the same page also, we will share our video and also our slides or whatever materials that presented during this session. Okay, so as a privacy reminder, video will be recorded. So everything that I say or we presented over here will be recorded. So please turn off your camera and also your mic if you are not asked to do so. And we will publish this video online later on our YouTube channel and social media account. So you can refer back, okay, to the presentation later on. Okay, so I also think that maybe some new comer. So let me briefly introduce RoboCup at Home Education. So we are an educational initiative in RoboCup at Home that promotes educational effort to boost RoboCup at Home participant and also artificial intelligence focused service robot development. And currently under this initiative, we are running 4 main efforts or activities. So the first one is education challenge event. So we have in the national level, regional level, and also international level. So international normally will run along with the RoboCup International every year. Okay, but this year due to the very special circumstances, we replace our physical challenge to online challenge. So online challenge 2020, we concluded last month. So if you're interested, you can head to our websites to see more of the details over there. And today we actually invite one of the winners team to do this sharing session. All right. So the second thing is like we focus also on open source robot development, particularly on service robot. So over here, we try to gather all the resources, the learning resources that we have to assist newcomer to learn how to develop robots and also learn about AI. And that links to the third initiative or third effort that we focus not just gathering the resources, but also regenerating teaching materials in terms of open courseware. So you can see like we have a lot of slides, presentation slides that you can use it for learning. And also we have online classes, and also we share our open source code. So you can use the source code, and we actually have the courses that you can follow to learn about AI and robotics. And lastly, outreach. So our main purpose is to outreach all these resources to the general public. So if, let's say like in your community, regardless whether you are a university, school, or you are just a hobby groups or any of you that interested in our resources and also content, we welcome you to contact us to see how we can bring these resources to your community in terms of, for example, like online classes or maybe physical classes or physical workshop as well, and also some exchange program and so on. So welcome everyone to contact us to do more, to see how to bring all these resources to your community, right? So if you want to know more about us, head to our website. I put a link there. And also we have a community in our social media. So you can join our Facebook page. Inside there, there's a Facebook group that you can join and also interact with our community, right? And lastly, I would like to thank all the sponsors and also our technical partner, as you shown on the screen. So they have been helping us financially and also technically in order for all our activity to be carried out. Okay, so for today, we have this invited lecture series. So we are actually running this invited lecture series ever since I think July. So we already have invited many experts come in to give some talks related to AI and also robotics. So and we have actually a few more in August and also in September. So at the end of this session, I will tell you more about what is going to happen after this, and we welcome all of you to join, right? And beside all this thing, we actually have our regular online class track that we have a 6-week course of introduction to service robots that you can have a look on the videos and also materials from website. And also we have the special online challenge track, which is focused on how to get ready for the competition. So these materials are all open on our website and welcome you to have a look. All right, so without further ado, I have done my introduction on RoboCup at home education. So now let's go to the main point or the main content of today. So let me invite the gray area from Macau Puiching Middle School. Right, so the gray area is an award-winning RoboCup at home education team from Macau. And then two very, great achievement by this team is like they won as a world champion for junior category in RoboCup at home education challenge 2020 and also for this online challenge 2020. 2019 and also online challenge 2020 this year as a gold award in junior category. Right. So for the team member, we have Joshua, Cristiano, Thomas, and also Sebastian, and also for their supervisor, we have Thomas and Kindle. But I will let the introduction, more introduction by the teams. Okay, so I will let the teams to introduce themselves after this. So so I would like to stop my screen and also I'll pass the mic to the gray area. So the gray area, are you ready?
Yes.
Okay, so I'll stop my screen and you can turn on your screen and also your camera or anything else. Okay, right. Okay, you may start now.
So, good afternoon, everyone. We are the gray area team from Macau Puiching Middle School. And in these 2 hours, we'll do our sharing section. I will discuss about our team development and also our learning journey of different machine learning and also how we came across to this competition. And we'll also have a very short tutorial about how to use color threshold to detect a bug. So we'll start now. So basically, we'll now our presentation will be in 4 parts. So for team introduction will be 25 minutes, and detection tutorial will be 40 minutes, and research and development will be 30 minutes. And at last, we will still have a Q&A part, so you guys can ask the questions at that point. But actually, you guys can also, if you think of any question, you can type it in the chat room, so we can also answer your question immediately. So because later we actually have a tutorial about using the color threshold to find out different objects. So you can now scan this code, and it is you can scan this code to install Python to a computer. So no matter you are in Windows or Linux, you can also download because we have a tutorial to it, and you guys can also because we also need PyCharm and OpenCV. But if you have all those things on the computer, then it's fine. Okay. So now we are now going to have our team introduction. So I'll give my mic to Cristiano.
So now let's talk about our team. So actually last year at first we got 18 team members, and then it becomes 7 team members to go to Sydney, and then it become 4 people this year. Yeah, actually why we are losing a lot of people because maybe they found their interest in different specific categories in our school in FedLab. Therefore, they have go to different specific category in our school. Yeah, so last year our team name is The Journey of Deep Thinking, and you can see here the photo of last year. Yeah. Yeah, so our team name this year is the Gray Area, and actually Gray Area is so meaningful to us, like the Puiching students, because actually we got a gray area. We really got a gray area in our school, and then this gray area is where we can play video games and we can play our phone when the teacher can't scold us. So it's pretty meaningful and pretty funny. So we have choose this the gray area for our team name. So let's talk about our school environment. Actually, so our Fed Lab is in Macau Puiching Middle School, and Macau Puiching Middle School is in Macau, and Macau is in China. So, so actually, you can see here. Actually, you can't find Macau in China because Macau is too small. But you can see Hong Kong here, and Macau is besides Hong Kong. So, so Puiching is about the middle in Macau. So yeah, you can see here is Puiching, and then this is the interior view of Puiching of our school. So here is a video like how we get into the Fed Lab. So you can see actually we just walk into the basement and then we can get to Fed Lab. So actually the previous area of the Fed Lab is a car park, and then we have changed this car park into Fed Lab, and then there are all the tools that we need, and we can build up our robot. So you can see some the tools that we need, and we can build up our robot by using these tools. So yeah. So now I'm going to talk about our testing environment. Actually, our testing environment is a bit small, but it's like a real-time environment that we didn't change our thing, we didn't arrange the seat or what, and then we just go for it for the testing part. And it's pretty comfortable to test here because we got sofa, and also we can sit on the sofa, and it's very comfortable.
So I think it's more like our environment is more real-time and authentic because we actually didn't make up our like own arena out. We didn't use some cardboards to make our arena out. It is more like a home environment. So I think that can like improve our testing.
So actually, time management is also a very large problem that we need to overcome. So you can see, so actually we got about 10 tests a week, and when it comes to some like time management, we really can't manage our time of the three of us. So sometimes we just we have divided our competition into 3 parts and let us to do our own part. And at last we have combined them each other to one part and then to achieve the function in the competitions.
So basically like our keys is to, for example, you can see in this image, the orange part is that is the test that we got in a week. So like in this pandemic, we got lots of tests, but for example, last year we still got lots of tests. So the key, I think, that make us still work, like make us still continue our development is that if there's no test, we'll basically work 3 hours per day or more. But if there's test, we'll just review it and we'll type it in Notion, which I'll explain it later. So I'll now talk about our learning journey. So I'll tell you how we can learn under this pandemic. So actually we use Notion and Zoom. So I'll now show you how we use Notion to still make our still let ourselves to learn during this pandemic. So this is that is basically our Notion. So as you can see here, we have a Notion page which write all our notes in here. For example, we made a to-do list in here. So you can see that actually most of the time it is in the March of 2020. So this is just the middle of the pandemic. So we use Notion to jot down what we have to do every day. For example, our teammates can jot down if they have to do the object orient in a specific time, and I'll also write down what I need to do. So I think this is a very important and vital role in our time management, because we can use this tool to let our other teammates, when they're not here, to understand more of what we are doing right now. So we also have a page of missions. So there are lots of strategies that we have come out when we are doing the missions. For example, we draw different, because at first we thought it is following the mission last year for this year's challenge. So we have write down lots of notes in here. So I think that having this tool can just let our thoughts be more clear and to let to improve our development. So, and the most important part is that I think it is the reference, because lots of time when we're doing programming, we might just search on some useful information. We might just bookmark it on our Safari, but actually I think bookmark it is maybe sometimes it will be complicated to find it out. So I think if we use Notion, so every teammate can also find a useful website in here, it is very useful. For example, we have different installation link in here, and we can also have some very, very important program notes in here, so that we can just follow it and we don't need to search for another time. So this is basically how we do our teamwork. So even though in last year we didn't use Notion, we also will use notes to write down our meeting notes, so that we'll remember what we have developed every time, so we won't be very messed up. So actually the reason why we can still do our development this year is because we use a lot of computer vision this year. So by using computer vision, we actually don't need to use our robot that much compared to last year, because last year mission 1 and mission 2 we need our robot to be there. But this year, because we have the final and we can just make our story out, so we focus more on computer vision this year. For example, we can look at this video. One of our teammates, Thomas Leung, is just testing in his home, so that we actually don't need to go to a school environment to test it. So he is now testing the OpenVNO's model of tracking different people. Because basically this year we used pose detection and object relationship and also person tracking, and we can do most of it at home. So we don't need the resource of robots, so we can still do our development in our own home. So now I'm going to talk about our learning journey.
So if somebody which is have been doing large projects or they should be managing them, so you may recognize this image, this bar. So this bar is GitHub's activity bar of a specific user, and this activity bar is me, and then you know that the contest start at June, and then also July we have one contest. So you can see here, and we have a lot of activities from April, to July. So we have do a lot of researches and knowledge learning.
So now I will just share one of our experience and memories of each member. So for me, my experience and memory is the mission 3 in the RoboCup Sydney competition. So the reason why I think it is a very treasure memory is because and then mission 3 we actually don't know what we need to do. We actually don't know what we need to do, and just at that time we get to know we have to do to detect different foods and different cans, and also we need to detect a yellow a yellow rain suit. So at that time we were actually very frustrated because we just have 3 hours time to prepare everything, and we're very tough. At that time I really sees out that every teammates in our team is doing the best, and I mean everyone is fighting for this mission 3. So I think this is very treasure moment in my life, and also in the RoboCup competition.
So that's because after RoboCup have make the rules public, it is already June, and then we need to prepare for July. So we have selected mission 1, 2, and 4 to do it. So we have lab mission 3 here, and also this is the first year, Sydney is the first year when we are attend to RoboCup. So we didn't know any recognizing and tracking methods. So we only know how to using conference so that we will talk at a tutorial. So this is a really tough time for us. Okay, so I'll talk about my memories. So my first memory, so I have 2 memories, which is very unforgettable when I am attending to Sydney. So first, I forget to release the emergency button when mission 1. So actually, at mission 1, the robot will need to move for a distance to do a lot of stuff. So you know that a turtlebot has an emergency button, which when you press it, it will stop the turtlebot moving for in case of if turtlebot has lost control. So at that time, I forget to release it, so the robot just stand here, which make us lost a lot of points. So actually, it had 2 chances to attend to the mission. So at the second time, we have earned back some points by checking everything clearly. Also, the second thing which is very remarkable is the messy project tree. So because during the mission, we will have a lot of softwares and programming files, so we will need a project or some folders to do it. But last year, we didn't know anything, so we just put the files at one folder. So then we find out that it's too messy, and then we cannot manage them easily. So at the end, so this year, I've made it more structured. So I have made it more structured. So and also I've grouped some type files into some folders, so it will be better than last year, like that messy structure.
Yeah, so I'm going to talk about our experience, like how we overcome some tough times. Actually, we got a lot of arguments in our team. Like sometimes maybe Thomas don't know how to express his own feeling, and then me and Joshua will got some misunderstand about him, and then therefore we got some arguments. But but the arguments will make our progress be slower. So at last we choose to like accept each other, the team members, and then we try to talk more, and then play more, and then we can be a good team.
So I actually have some also additional message of like actually how we learn through this 2 years journey. So basically our teachers we didn't have a scheduled lesson to for example which week or which day we need to learn. So basically we just come to the lab after school and to work for 3 hours. So basically we didn't have a class, so we're just exploring and doing our own code. So when we have different difficulties, we'll just ask our teachers. So I think this is our method of learning. So So I mean, we just don't have a static timetable of when we need to come. We just come because we're like passionate to do it. So we just after school we just work for it, and we just don't have a static timetable. And I think that having this habit is much better than maybe a class, in my opinion, because it is just like our own passion. But if you are going to a class, it is more like maybe it is forced to do it. So I think maybe this is one of the reasons why we get the champion in 2 year row.
Yeah, because like we found our interest and we found our passion in this place, and yeah, we really like to do the things that we want to do, like the robots. Yeah.
So we're now going to start our tutorial section, and now I'll stop sharing my screen and I'll let one of our teammates to share his screen. So basically in this tutorial, if you have installed for example, PyCharm or Python or OpenCV in your computer, you can slowly follow it. So I'll talk basically what we'll do in this tutorial. So basically we will just detect some red objects using the color threshold of OpenCV and Python. So this tutorial section will be held for about 30 minutes. So we're now going to start up. So one of our teammates have already turned on his to share his screen. So he'll now going to explain the tutorial.
So I will be in charge of the tutorial session. So I'll first show that what is the result of our tutorial session. So I'll first show our session of the session. So in this tutorial session, we will holding red colors out and then avoiding other colors. So you can see that I have a red book on my hand, and then at the mask frame, you can see it has successfully thresholded the red colors, and also my lips at here. So you can see things which is not red will be deleted. So I'll now start to teaching how to use it. So because I only have 30 minutes to talk about decision, so for the basic program, I'll just type it out and then I'll explain it each line. So you can, if you wanted to copy it, so when I'm talking this, I'll give you some. When I'm talking each part, I'll give you time to copy. Okay, so I'll start first. So I'll first talk about the first line. So we in the installation link, we have told you how to install OpenCV. So also install the Python wrapper of it. So because it is a third-party module, so in Python it won't be included at first. So we need to include it first. So at this line we will just import it. So the name of the Python wrapper is CV2. The second line here, the fifth line here, you can see that, because we will need to first open our camera, because you can see I've opened my webcam there. So actually this video capture is getting the so this is getting the certificate to use the camera, because the camera at first it is locked and then you cannot use it. And this line we will use it, we will get the certificate of using the camera, and then this one is the certificate. So now we will end. So now I'll talk these lines first without talking this line. So this line first, we will read the camera for. We'll read the camera frame from it. So because we know that video is combined, combined frames, and then we're just switching it, moving it like a video. So we will reach each. When we run this line, we will read the frame that the camera read. Down here, that because we have operations which we need to use the frame at here, so we need to ensure if the frame that we can read the frame, because camera maybe have some delay, so it cannot read the frame. We need to check if it successfully read it. So we have this line for checking. If it didn't read the frame, these lines will never be run after we read it. After we read it, and then we will be run these lines. So these two lines here is to show the frame out. So this is the window name of the frame, and then this is the And this is the, because after we show it out, so maybe wait a sec. So here you can see successfully show my, you can see it successfully show my webcam out. So this phase, this parameter will be the window name that will show the frame, and then here will be the frame that we're using. At here, because we will need, you know, as I just said, video is combined frames which switching each frame in a specific time. So this is the delay between each frame. So so now I'll talk about why we have this line here. So that's because if we just run this line, so if we just run this line without this line, so this line is actually open an infinite loop in here, because this line will only read one, the F line will only read one time from the frame. So if we wanted to let it have a live stream here, so it requires us to run the frame here. We require us to have a loop here. And also down here, this will be a break statement, because I just said that this is an infinite loop, so it will never terminate this program. So I'll give it a state to terminate, which is if I press the key Q or escape in the window, so it will escape it. Also, these two lines is this line, the 20th line will destroy the window after I press the statement key, and then this will release the certificate of using the camera. That's because we have saved the certificate to our memory. If we don't release it, it will just save it inside. After we run a few more times of the program, then it will be saved more and more, and then your memory, maybe it will be full. So we release it every time. So now here we have done the basic to open the camera. Also at here, I will do a ROS version of it. So in the installation link, so I prefer here, you can see that I have told you guys to install the USB camera. So this is actually a ROS node that will open our webcam to do it. So I'll first launch my terminal, and then I'll first launch that node first. So if you open the ROS viewing topics image application, you will see that we have successfully read the image from here. So I will now open the ROS version of it, because of the time limit, I've already typed the code of it. So I will do a compare here. Okay, so I'll do a compare here. So I will stick it back to lines, compare in each line. So now the differences between ROS and our original world is we will need to subscribe the camera topic from our. We need to subscribe the camera topic from our USB cam, and then we will get the camera from it. So these lines are also the same. So I'll talk about these lines up there. So this is creating the subscribe bar to subscribe the frame and the image from our USB camera. So at here you will see our topic is compressed. You see a compressed word here. So actually the USB camera node will have provided a lot of images, which has raw images and different formats. One of the format is compressed image. So we use compressors because, as its name, the image is smaller, and then it will have faster transfer speed. But if you have this, also you can use image raw in your computer because you have local transfer. But I suggest you to use the compressed image for you will have better use in the future. So we know that after subscribing the topic, we need the message type. So upside here, we'll import the message type inside here. So after importing it, we'll also need a callback. So here we will get the image from here. So because we will need to, because this callback will change the frame each time, because there's a subscriber after it has get the message from the topic, it will run the callback. So here I will just get the frame here into the callback here, into the callback function. So now talk about here, like here, why frame is non-native first. So that because inside here we'll have defined frame inside the loop every time when you read the frame. But now while we read the frame, it is outside of the loop, so we will need to global it, make it a global variable first. So I just the image is compressed, but OpenCV CV2 is using a image array, which is the raw image. So in order to change the compressed image back to a raw image, we'll use a module called CV Bridge. CV Bridge is a module which can turn raw image message back to CV2's CV2's image array. So here we will call CV Bridge here, and then we'll just call its method to change the message of compressed image back to image raw, the OpenCV's image array, and then it's same as here. So I'll now run the raw version of the program in my terminal. So it takes some time to start. So you can see it successfully start up, and then you can see my face here. So now we will have the basic of how to read the camera with OpenCV2, and then also the WAS version of it. So now I will start doing that. What we're going to do in this tutorial session, which is which is thresholding colors from thresholding specific colors from our image. So now I selected red here. So I'll now talk about how thresholding works. So actually, OpenCV will read every. So we know that images are using colors, which is RGB to do it. So we know that every images are combined with a lot of pixels, which is very small, and also there are values of it. And OpenCV will first read all of these pixels and their RGB values. After reading it, it will first calculate if it is a red color, which is in a range of it. So if it is, we will just save it down, and then just like any other things. And then after checked all pixels, then we will get the image, and then we will get the mask that I just showed it. That I just shown at the window mask. So at here, so I just said that OpenCV will get the color using it will look over every pixels, and then we will get the color, and then we will check if the pixel is in a specific color range. So actually, OpenCV cannot define if that color can threshold anything. OpenCV's method, which is CV2, can threshold any colors according to the range. So at here, we need to get the range of red first. So at the notion, I've already get the range of it, which is the range of the red color. So you see, lower red means deeper red, and higher red means brighter red. So I will continue right now. So actually so I just said that we will loop over it to see if the pixels color is in the range of our specific color. But we are not using RGB right now, because in RGB you need to tune the color, red colors are very complicated of it. So we will use another color model, which is called HSV Color Space. So HSV Color Space is combined. So as RGB, we have the red color and the blue color and the green color. And here we will also have three values, but in difference. So H will first have the hue value, and then we will select the colors. So you can see it has cyan, blue, red, and purple, and also other colors set here. And then the S value, which is the saturation, will set the saturation of the color. Also, the V, which is value, will set the brightness of it. So when using this, using this color space, we can easily get the range of our color which we want. So if we want to use red, and then we'll go to here, and then we will select this red color, and then if we want it to be darker, we will change this V value and then up and down. And then also, if we want to set the saturation value, we can also set it very easily. So at here, we have just set it. So at here, red color is between 170 and 180, and then we'll get the saturation, which is from 70 to 255, and then the brightness also. So as we just see, the hue value is actually a plate with 360 degrees, but in CV2 it has just divided by 2, so it has lesser colors which only have 100 degrees. So right now we will call CV2's method to threshold the color from our image. So the method here is called CV2.range to threshold the color from our image. We know that this color is in HSV color space, but this frame is in RGB color space. So we need to have to change the frame into HSV color space at first. So it will be done by the method which is called CV2.CVD color, which is the sort of convert color. So we will first put our frame which we want to convert, and then we will put what color we want to convert, which is the color code. In CV2, converting RGB to HSV, we will type this at the bracket here. So, and then we will just get a HSV frame out. So I'll now show that I'll now show the HSV frame out. So you might notice that it's a little bit weird on the color at HSV color space. So there is an error. So that's because OpenCV showing method will use RGB to show the image out. So it will be weird when you are using HSV workspace. So you can see I'm in green right now. So now I will start doing. I'll now just convert the mask right now. So it's just same. I just type it. So first we'll put HSV inside here because we are using HSV color spaces at the mask range. So I'll now show the mask out. So you can see it has successfully thresholding frames out. So at here, you can see 2 frames, which is the original frame and the mask frame. So you can see the position, which is my lips, is kept at here. So because it is red, and also some parts of my skin has been kept because also it fixes in the range of red. So now I have a red book at here. So you can see it has successfully thresholded other colors, which is not red out, and then capping red at here. So here's also a red shoe here. So you can see it successfully thresholded it. So because it wasn't truly red here. So actually this is Joshua's shoes. So now I'll now do it in RAW version. So it's at the same as the original version. So I just copy the mask first to the ROS page, and then I will copy the code which could threshold the mask, which will threshold the color from it, from the original frame. So now I'll do a compare here. So now do a compare here by entering in the parts from the same line. So here, so please wait for me a second. So now I have successfully copied the code which can threshold colors into the ROS version. So now run the ROS version at here. Oh, sorry, I need to start the camera node first. So here, when I bring my book, here you can see my book at here, and it successfully thresholded it. So because this is a compressed image, so after decompressing it, some data may be lost a little bit. So you can see that here. So you can see that the image quality isn't very good at here. Also on this shoe, you can see it is really bad image quality. So also this tutorial session, I hope everybody has learned how to threshold the color from it. So actually last year we have used this program for on mission 2 because mission 2 last year we needed to use it to recognize a red bag, and then our manipulator will follow the red bag, and then we'll just grab it. So this code will be useful for for all listeners. So in the future, maybe you can use it in any areas. So actually, I hope that you have learned things. So my tutorial session has ended. Thank you. So now, after my tutorial session, Joshua, we will talk about the hardware development. So, which is a little bit about our hardware. So, because we have redesigned our robot, so you can see at the left of our screen. So, we will now talk about it.
So now I'm going to talk about the research and development, which is you might be more excited about it because in this part we'll talk about the machine learning and most of our features and how we do our research and all the development behind it. That's it. So I will start by talking about our hardware development. So at first, I'll show you this introduction. So this is basically our robot. You can also see in our webcam because maybe the quality is not that good. So this is our robot, and basically we build our own robot. And I see actually a lot of team might be just used Moostar robot with the turtle boss, but we used that design last year. But in this year's competition, we just changed all the design and we just built our own robot. And this is our team name. So now I'll just talk quite about what our robot have. So first we have our manipulator. So the manipulator is on the top of the robot and it can clip a lot of objects. For example, last year we can use this manipulator to clip a bottle and also clip the bag. I'll show some videos later. So and below we have our RGBD camera. This RGBD camera can let us to do the pose recognition, object detection, and also animation, which require our camera to do stuff. So, and the second point is our microphone. We can basically use our microphone to communicate with our users and also to us. So in last year's mission, we have mission one, which basically is that we need to communicate with the robot, with the human, to interact with it with some question and answers. It's like we have to ask the robot some question and it needs to answer. So we need the microphone to do it and also the speaker. So the emergency button is basically, everybody knows, is very important because we need to stop our robot immediately in some situation. And this purple part, the storage area, is very important because this storage area basically we just build it because we think that having a storage area in a home robot is just make our robot more like a user-friendly robot, because by having this storage area, our users can put his bag or even the bottle inside of the storage area. So no matter, even though the object is heavy, our robot can still carry about it. But for example, last year's project, last year's robot, you don't have that capacity to put the stuff. So in this year, we just redesigned our robot. And below it is our camera too, which is for the SLAM and AMCL detecting. So it is basically the same as the top camera. It is also an LGBT camera. And the most bottom is the Kabuki base, which I think maybe everyone used. And this base is basically just drive our robot in front and move our robot.
So I have a little bit more to talk about the storage area. So because we have designed this robot to go out with his master, so we will have designed this storage area to having carry things in the street. Like if you go to the supermarket, this will be for the market bag for it.
So this the three versions of our robot. So first one is the robot we used last year, which is the Musa robot. So it's basically the same as maybe some of your robots. And this, the version 2, is the robot we used in this year's competition. And I've just explained it just now. So the version 3 is I've drawn this in the SolidWorks, which is a 3D CAD software, but I haven't finished it. But my thought is to have more storage area and maybe make the storage area more private so that everyone won't see it. So there might be a box to store some tiny things in there. And in that, so you can see in the version 2 and version 3, and like this, despite of the storage area, we have also changed the angle of the screen because I think that is more user friendly. Because in the first year, no one can see the screen just if you are just sitting on the floor. So I believe that like turning the angle of the screen can let maybe more users to view our screen and to be more user friendly. So the system structure of our robot. So basically our system is divided into two parts. The first one is emergency detecting system, and the second is the basic home services. So for this first one, it is basically with the network. What do you mean network is that the transmission information towards the computer and the robot, and also the speaker and computer vision to inform the instant situation to others, and also for our post detection, object relationship, and also our machine learning. So basically our machine learning are used in the emergency detecting system. And for the second part is the home services. That means that our robot can do the basic communication with others and also use the manipulator to clip objects. So Cristiano will now talk about the manipulator of how actually we can to accurate and to grab an object by itself.
Yeah, actually the manipulator plays an important role in carrying object in our competitions. In order to let the manipulator to grab the object precisely, we have divided into two parts. So the first part is the camera and the second part is the each servo of our manipulator. So let's talk about the first part. So in our robot, our camera is actually at a fixed angle, so it can only capture one photo, like one capture photo in front of it. So the size of the captured photo is 640 pixels x 480 pixels. So firstly, our camera is known as a depth camera So which means it can get the distance between the scanned object and also the camera. So when our camera get the value of the distance, we have used the OpenCV to ensure the coordinates of the object, and then we use the proportion calculation to calculate the real distance of the real coordinates of the object. So after getting the exact coordinates of the object, it comes to each circle of the manipulator. So you can see here there are a lot of calculation here, and we mainly use the cosine theorem to calculate our angle of each circle. So actually, the L3 is in a fixed angle. We have set it as a zero angle. So therefore we can calculate each angle of each circle. Yes, and this is how our manipulator works in order to carry the object.
So we are now going to show you some real-time like testing, not real-time, but just some testing videos of our manipulator. So basically you can see here, so our robot can follow the red back. So this method is basically this method we actually basically used the method just now. Thomas Leung have set it out that tutorial. We have used the threshold of the color to detect the red back, and used the function of Cristiano, the manipulator, to follow the red back. So another video is that our RGBD camera. So we've used the green threshold to find out this bottle, and also we use the RGBD camera, the depth camera, to calculate the distance between the robot and the bottle. So moreover, you can see that this is a bottle clipping video. So this is actually used two of our knowledge. The first one is the threshold that Thomas Leung just now said, and the second one is the manipulator calculation Cristiano said just now. So basically, I have to find the middle point of the whole green area and do the calculation just now to clip the objects in here. So there is one video from our competition in last year from the RoboCup in Sydney. So you can see that our robot can clip the green object by itself. So this is basically what our manipulator can do. So now I'll continue on the presentation. So now I'll talk about the object relationship. So actually what object relationship means is we can find the relation between humans and its surrounding objects. So I'll show a short video of actually what it can do. So basically it can just find the main character and also find the objects next to it, and we can find a relationship between it. So for example, I can detect some chairs just now. So actually the software development of the object relationship is divided into three parts. So the first one is to use YOLO to detect everything in the frame. So I'll explain YOLO, what is YOLO later, and how you can install it. So basically, I can use YOLO to find humans and also find different objects. And the part two is that we can find the main character. What the reason means by main character is that we can find the most center, the people that is most near to the center and also most near to the robot. And the part three is to reduce some far objects and also some very small objects which we don't need in our object detection. So the first one actually, YOLO is I will now let Thomas to explain more about what is YOLO and what is YOLO and how we used it here.
So actually, YOLO is an object detection model method which is invented by Joseph Redmond. So this method is so now the model that we're using is trained by the inventor, and it is trained with the COBO data set, which has a lot of categories like you can see it here: animals, vehicles, outdoor objects, stores, or other things. So person is also.
Yes.
So Joseph. So before YOLO, there are a lot of methods to do object detection, but there are also with low accuracy or other things. So before we using YOLO, we will try to use the single shot detector, which is called as SSD. So we have found that it has fast speed, but it has low accuracy. So then we last year at Sydney, there's a technical sharing session, and then we know that there is a team using YOLO, and then after testing, we find that its speed is normal and is fast, but not as fast as the single shot detector, but it has high accuracy than the single shot detector. So then we have used YOLO as YOLO until now to do our projects to it. So I'll explain about person follower later. So we'll be using YOLO also.
So basically, we used YOLO to detect these objects. You can see that we can also detect furniture, which is very important in our home detection, like in our project, because we can detect different objects, for example, TV. And by using this, we can let our robots know where our humans is next to. For example, if our humans is next to a chair or next to a TV, our robot can tell it out. So the second one is to find the main character. So basically, how we find, I said just now, is to find the human with most center to the middle. So you can see that we have actually divided the screen into four parts. So if we just use the XY value to do some calculations to see whether the human to compare the two humans or the three humans or more humans in a frame to see which is more near to the center. And you can see in this video, actually, we have two people in the frame. So the first people is in the orange bracket, which is the main character. And when he leave, and it will become Sebastian, which become another main character. So I'll now talk about actually at last why I become the main character, and that is because my rectangle is biggest in the frame, so it will choose me as the rectangle. So what this means is that not by only just the human is more near to the center, we'll also find if the people is more near to the robot and more just next to the robot. So the last one is that we can reduce also far away and very small objects in the frame, because in reality there might be a lot of noises, and we use this to do a noise reduction method to just deduce other objects. So actually how we do it, we just set a valve of it so we don't detect very large objects. For example, if there's a human, for example, if I'm standing here and a TV is behind me, or maybe I'm very far away and that TV is behind me, I won't say the relationship between me is like I'm just next to the TV. So I'll use the depth camera to detect the distance between me and the robot, and also the distance between the TV and the robot, and do this calculation to see whether the TV is next to me or not. So this is the application, as I said just now, is that we can find a relationship between the humans and objects. And you can see it can detect, for example, handbag and TV, but at that time, because we still haven't developed, just now I said that, to detect whether the TV is far away or not, we just haven't put the depth camera parameters of this variable inside. So yeah. So now I'm going to talk about the post detection method of this feature of our disease project. And this is actually very important because we have just self-developed almost everything. So this, you can first watch this video, and you can notice the different action and also posture of our human. For example, Cristiano is now squatting. He now fell onto the floor. He can use the skeleton to detect his action. You can see on the left top camera, there's the status of this human. Yeah, so we can notice the danger of humans in different situations, and I think this really helps us a lot when we're in home environment. So I'll now let Cristiano to tell you guys about actually our evaluation of this post detection. So actually, our aim of post detection is to ensure the safety of different humans in the home area. So we hope that we can use this method to detect like if the elderly or if someone is found on the floor, it can just notice and let them notice and let more people to save them immediately. So the first method is average value method, and Cristiano will explain it.
Yeah, so talking about the average value method, so this method we didn't use any machine learning. So actually how it works is we use the OpenPost library to get the different points of the human body, and then we have sum up their y value, and then we have calculate and we have export their the average value of the y value, and then we have divided our photo into two parts. So it's the upper part and the lower part. If the average value is in the lower part, we will consider it's a fallen situation. Therefore, we can distinguish if it is a stand situation or fallen situation. So why we don't use this method is because when it comes to like if a human is sleeping on the bed, we can't distinguish if it's sleeping or is falling. So the other method is the SVM method, the support vector machine. So in this version, we have used the machine learning. So you can see here is our training data set. So we got 3,085 images in order to train a high accuracy model. So you can see here are divided into two categories. One is the danger and one is safe. So actually,
you can see here we just basically we just used our RGBD camera to get the frame. And we used the OpenPost library to draw the skeleton of our human body, and we put this skeleton into a black background, and we use that for training and yeah. So actually the reason we put danger and safe is that if it is in the fall category, we'll say it's safe. But if it is in the squat, stand or sit, it will also be safe. So yeah.
So let's see. Actually, we have three main categories in our data set. So one is danger, one is warning, and one is safe. So you can see we will consider when you are squat or you are sitting, we will consider a warning situation. So this is our testing data set. We got about 200 images in our testing data set in order to test the authentic accuracy of our model. So here is the diagram of our testing score. So we found out, so actually we changed the training rate of each model, and then we found out if the learning rate is 17, it has the best model. So this the training, the original dataset training score, the original dataset testing score, and the brand new dataset testing score. So actually, we can see the highest is 75% in the new dataset testing score. So we'll consider it's the best model of us.
So now I'll talk about the model that we're using. So actually,
So we're now going to just explain the CNN because we have three methods. As you can see just now, at first we have the average method we just like maybe invented, and the second one is the SVM, and the last one is CNN. And we found out that the CNN is most accurate, but at that time we actually didn't make lots of data about it, so we're just going to explain the structure of CNN.
okay. So actually, we are using a model which is called VG16, which is a model structure tested by a professor. So we have it's called fine tuning to use the model. So here. In CNN convolution neural networks, we have divided two parts. The first part is the convolution layers, and then the second part is the neural network. So the convolution layers is a lot of filter. It's a bunch of can filter the image which can filter the image and then keep at last it will keeping the required parts, which is a mask, and then the neural network will take the mask into it, and then it will evaluate the result. So actually, and the VG16 model, actually, in convolution neural networks, the professor which has been tested is the convolution part, which is the filters. So that's because the neural network the neural network is easier, but how you can filter the images to keeping the important data. So this is very important of it. So the professor has tested with his own version of the filters, and then he named it VG16. So that we uses VG16's convolutional layers and then combine it with our neural network part, which is the network, and then we'll output it outside. So there are a lot of other models, other convolution filter models outside, which has invented by a lot of people, like ResNet, GoogleNet, InceptionNet, or like DenseNet. So we use VG16 is because it is easier than other neuron convolutional filter networks that are talking like I'll give an example, like InceptionNet. It has a very difficult structure, and also as GoogleNet, which is based on InceptionNet. So VG16 has a clear structure, which is more easier. So then we use it as our model. So also, so now it's been one more time. So here we'll input the image inside, which is the skeleton of our poster, and then we will give it to our VG16 model, and then we'll give it. And then after we get the important parts, we will give it to our neural network, which only had 2 layers, and then we'll output the result outside. So our result have 4 items, which is for squat, stand, sit, and fall. So now Cristiano will talk about the training process and other things. So I will.
So let's see the disadvantage of the first 2 versions. So the first version, average value method. So when it comes to like, if a person is sleeping on the bed, we can't distinguish if it is sleeping or is a fallen situation. So why we didn't use Therefore, we have found the third method of us. It's a CNN. So now let's Joshua to talk about the CNN.
So actually, I can explain it like more easily. So actually, SVM we just used the skeleton. So we just used the different points of the skeleton to train our model. But on the CNN, we just basically put the whole image inside to train. So our machine can know that can know just the relationship between the skeleton and also the environment in CNN, but it don't know the relationship between if it is very far away or it is very near to the camera or not. So I think that CNN can just get more about the information of the skeleton, which is a human, with the environment. So this is like much better than SVM and the first method. So at our last part, we'll just talk about our follow me. So this follow me feature, actually, we just used 2 years of development to finish it, because in last years we just like do some very little changes to the original follow me, but in this year we just changed a lot, and we just you can say we just used our own method in follow me. So Thomas Leung will continue this part.
So I'll now talk about the person follower. So actually we have 2 versions of follower. So I will let you see the first version.
And the first version is basically no image processing. So you can see more clearly, actually you can see that. So now the robot is following Cristiano, but when Thomas will come over, the robot will just follow another person. And we have also tested that the robot, like the original follow me, will also follow the angle of the wall. So this is a disadvantage. But this year we used image processing. You can see that even though someone walk across, the Cristiano and the robot won't follow another person. It will continue to follow Cristiano. So we are now going to explain the magic inside.
So actually, we have you see on there we have used a magic, but actually we have pay some prices for it. So that's because you can see this for the phone, which is the original one from the official, has more moving speed and it can react faster. But after we using the magic, we need to slow down the speed for its accuracy. We have to slow down the moving speed for its accuracy. So now I'll show what the robot. So at first. So at first, you can see it register target, and then we will put green boxes on the target, and then red boxes for the, and then we'll put red boxes for the non-target person. So here, somebody has come to inside, and then it is marked as red boxes, and then you can successfully avoided the person. So maybe you have some accuracy problem. So you can see I have been marked as red. So now you can see the robot is following me. So here you can see it can identify the non-target person only, and also you can see it can still identify it if even the person is beside me very close. So here I'll first talk about the versions. So actually, before the magic version that you've seen at right now or at the live demo, we have a lot of versions before. So I'll talk about 5 of it. So we have the first version, which you see as which is a clone of the official follower. So that's because we don't want to use things which is always from other people. So we have to make our versions. So we have clone it. We have a clone of the original version, and then we can find issues or other problems inside. So one of the problems is that is shown at the comparison video. So at first, at the phone, as Joshua has said, it cannot identify a object or a person. So it don't have any idea of what is forward.
Yeah.
And also it will follow the wrong person. So also version 1.1, so this is the first year when we are attending to a contest. So because after the RoboCup group has the rules published, it's already June, and we have the contest of July. So we have only add some screen size cropping or avoiding everything. So and then we'll go put it on our contest, which only still have those problems. So after we have our link, after we have the contest of last year, next year we have used the YOLO. So after the Sydney contest, there's a technical sharing section at there. and then we have used, and then we know that there is a team using a technology called YOLO. So then we test it at home at the epidemic, and then we successfully used it to recognize, to identify an object or a human. So now the robot has a little bit idea of what is following. So, but he didn't have an idea of which person is his following. So in 2.1, we will try to let the robot have an idea of who it is following. So we have used several tracker algorithms like the DRB correlation layer tracker, or some deep learning trackers or other algorithm trackers from OpenCV or other things. So then we find that those trackers are trained to track a lot of every objects, to track anything that we have that the user give it. So it has low accuracy on tracking a person or other things, so which is the average accuracy of tracking things is very low. So like this, so maybe it will follow another person when it is tracking a lot of times. So after we have we have searched over the internet, and then we find that OpenCV has a model which is pre-trained, which is called the person identification model. And then we used the model, and then we can see that it could now identify me and then the person had two persons clearly. So then we have used it in the forward now. So now, because it is very meaningful of the first version, so I'll talk about a little bit about first versions. So the post detection has a lot of methods that has tested. So a lot of methods that have tested. So this is the first method, which is which I call the depth point search. So at first, I will get the image, the depth image. So which I just said. So the camera that we are using is a RGB camera. So the D camera, which is the depth camera, will get an image of pixels, which is represent the distance between the points in the image in centimeters. So after I get the depth image from the camera, I'll first find the closest point to the robot, which means if I'm now standing at my hand is now covering on the camera like here, it will see that my hand is very close to the camera. So I'll now find the points which is closest to the camera. So now if you imagine the robot is seeing my hands, it is now close to my it will find points which is over my hands. So if anybody right now is looking at the PowerPoint screen, I hope that you can now change to also look at the webcam screen, because it wasn't amazing here. So at the second point, after we find the closest depth points, we'll find the depth point which is closest to the centroid, which is if now I have a lot of depth points at my hands, and then I will only find a depth point which is at here because it's closest to the centroid. So we'll treat the point which is closer to the centroid as the point that we are going to follow. After we get that, we will import this to two P controllers, and then we'll command chassis to do this. So this is the method first. So it has the issues that we have talked about in the comparison video. So we will go next. So actually, to this year, so I just said that last year we have used the P controller. So this year we have used the PID controller. Okay, who make it like this? Okay, and we use the PD controller because we didn't to use the integral. So actually, the PID controller has represented in 3 terms, and then it will calculate 3 terms, and it will plus any value, and then we will get the value output. So because the integral term will be used in other situations, so we didn't. This situation won't exist at the home environment, so we didn't use the integral term right now. So about OpenCV, I'll talk about it. OpenCV is actually a toolkit developed by Intel, and also it is a fast toolkit to develop a deep neural network or run it, evaluate it. So here you can see that it has a lot of pre-trained models. So this the person identification model is one of it. So So here, the image part you can see here, and we have the initialized image, which is the person that is moving forward. And then if you can see, it compared this image to this image. So you can see it has successfully identified that which person in this image is same to the person that is initialized. So here you can see that this person, the persons which has been marked as non-target has a same color of their coat, but they have different trousers. So you can see it. There's a differences here. Go back. Go back. So YOLO, as I've just talked a little bit about YOLO in Joshua's session. So I'll now play a video of it, which is an example of YOLO. So you can see it successfully identified a lot of persons that here, which is a lot of persons in a fast or an accurate. So I'll play it for one more. Okay. So after we combined our YOLO, which is the version 2.0, and then our OpenCV model, we'll get the new method that we're using to follow. So at the new method, first we will detect objects in our screen, but only persons. So and then the second part, we will crop the person frame out of our image with the boxes that we get, and then we will run person re-identification model on each person after cropping it out of it. So now I'll talk a little bit about how the person identification model works. So actually, the person identification model can, after you input a person image inside, a person image inside, after you import it inside, you will get a descriptor, which is a factor of it. So because after its training, same persons in the image, the descriptor will be similar, will be more similar. So how can we know that if two factors is similar? We'll compare two factors with cosine similarity. After getting the cosine similarity, we will get the similarity between two factors. So and then we will use the similarity to treat if the person is same as our target person. So the similarity. Because the model has been trained, if the image that we are cropped out is same to an initialized person, the similarity will be high after we trained it. So now we're using it to similarity to find out the target person. So after getting it, we will get a Ross graph at here. So because we're comparing with Ross, so now I'll also have it. So now I'll also talk about something which is at the live demo, there's a contestant has asked us a question, which is how can we still have fast speed when we are if we are running a lot of neural networks? So now I'm going to answer this question right now because at the time limit doesn't require us to answer it. So Jeffrey has just shut it down. So actually, we have divided our system into our robot part and our client part. So our client part will be a gaming laptop which has high processing powers to help us to process these images. So if the robot here it has data which requires to using neural networks to process it, it would send the data back to our client, which is our gaming laptop, and then the gaming laptop after processing it, it will send the result back to the robot. So now I'll talk about how it works at here. So first, we will get our extra camera. We will first get our RGB image to our client, and then we'll as we have just said how we use the core part. We'll run the RGB image input the RGB image into the YOLO box detector, and then we'll output the result back to our node. And then also after we have get the box inside our person forward node, we'll run the person verification model, the detecting process to find out the target person. After finding it out, we will have the target person's box coordinates and also the centroid of the pilot box, which is the center of the box. After it, we will send the central box. We will send that box centroid to our robot, and then our robot will have a node to get it, and then the robot will get the depth image from our extra camera from our camera to find the depth point value using the box centroid, and it will send the depth value back to our person back to our computer client. After it, we will use the depth point and the depth point value and the box centroid to our two P controllers. One is used to control the turn speed, and then one is used to control the robot to gain, let's say, same in a range of distance between target person and itself. And after getting the forward speed and the turn speed, we'll comment the chances to do it. So you may ask, one question is, why we divided two nodes between the client and the robot? So that's because we have found that if we subscribe depth image and the RGB image at once to the client, there's a problem is there is a delay between it. Even if your rotor is faster, there's a delay between it. So that's because robotics detector will need to run the image for some time, but after running it, we will already get the depth image. So two image isn't the same. So we require us to use the depth image at the robot to get the live image from it. So now So now we have already ended to talk about session. So now I'll get back the mic to Joshua to talk about your suggestions about it.
So I just have some little bit suggestions to for like some new teams of joining to this competition, or even though you're old team or you want to improve your development. So the first suggestion I want to make is to have a good time management, and I believe how we can get a good time management is to use the tools that we such as now Notion, because I really think that Notions can really help us a lot of just getting our research data, and also getting what each members need to do. Yeah. So what each members need to do. For example, in here we will just make like some install instructions just now. So I mean, in using Notion, we can just get more clear of which what we need to do every day, and also conduct the main idea of how we can just finish our project on time. So the last sessions I mean is to work hard, because I believe that working hard is very important. So for us, actually, during the pandemic, even though maybe we're stuck at home, we won't stop our development of like, for example, the robot computer vision development. So for us, like most of us, we like work for more than 3 hours a day in school, just after school, and when there's test, we will still drop down what needed to do every day. So I think that working hard is the key of every development.
So actually, so I just said that Joshua has talked a little bit about Notion to drop down your notes. So I'll talk about a little bit more about Notion here. So now I'll share my screen for using it. So to talk about Notion. So actually we have Notion could help you to create like references, like there's some links here. Also, if you will need to drop down what you need to do, it has calendars which you can drop down every day you need to do, and you can drop down everything that you need to do it here. So this is it. So like here, you can see that. So you can see that we have a lot of things like notes that we want to do. So you can see that we have the title of what we want to do here, and then the date, the range of the date, and also the stages of here. And also we will have some comments like these here. And also we will have some we'll have have a table here. So like if we have a table here, we can check it or not. The notes at here will have a total list. Also, it supports for you to importing images, GIFs inside, also some drafts here, and also with some other things. So one feature I would like to talk about is the code feature. So that's because you can type codes in here and then you can select the language. Okay, so I have already talked about that. So I'll get back to the main section.
So at last, I've actually have someone to conclude in here because actually we didn't wait a second. So actually we didn't show much about like our team presentation and the final demo. So I will send this to the chat room and you can just have a look if you guys are interested. So this is the final the video of final demo on the date, and this is the video of like we just film it ourselves, and it is the introduction and also like just the introduction of our robot and all of our journey. So you guys can type use this link to know more about our team and to just get to know more about our team. So basically our presentation is so here.
So actually, as Josh has said, that we have our introduction video here. So actually, having a good introduction video or a demonstration video is very important. So that's because it can let more people know you at the community. So you need to have I suggest you to make your introduction or demonstration video more harder, so you can let more people to know you, and then you will have more chances for people. So thank you everybody to listen to us.
Yeah,
so now we will have our Q&A session. If you have any questions or things to ask of our presentation, or if you have questions to ask in our live demo, but just Jeffrey had, but we want to ask, but the time limit problem, so you can ask it right now here.
Yeah, I mean, like, yeah, thanks a lot for the very
Jeffrey,
interesting, yeah, I hope you can hear me, right? So I've turned on my webcam and mine as well. So once again, I would like to say thanks and appreciate a lot your hard work on putting this presentation. It's amazing that I actually personally don't expect this amount of information that you're going to share in this session as well. So I mean, like, your presentation is very technical as I don't really expect that you actually share all these things that and the way that you present your how to say, the overall arrangement and also your presentation and also your development. I think like is something that a lot of teams can refer. I mean, we can actually learn a lot from what you have presented, and I'm sure like this video will be very useful for a lot of new teams out there, for newcomers, and also especially knowing the fact that I would like to stress on this point that these people that just presented, they are just middle school, right? So you are like middle, maybe you can say like you're in which level? Middle, I'm not sure, like secondary year.
Yeah. Three of our teammates is in high school, like we're 16 years old, and one of our teammates is in 14 years old.
Yes. So
we need to like here, Thomas. Yeah.
Hello.
Right. So over here, I would like to stress this to tell the audience that based on your level and also your level of education, and you can present such materials, is really amazing. I can say it's really amazing. So I really hope that later on I'll put this video on YouTube in our channel, and also I will try to include all the materials that you were willing to share. And really, I think this is a very amazing and very touching, because like finally we can really see that AI development, machine learning, and all this thing is not exclusive for university and above. I mean, like, it's no longer just something that for research purpose and so on, but now even like we can do this in a very normal education, in high school education, and also people like you who I'm not sure about your background, but I assume everyone should have some idea what we learn in high school. And with your mathematics and physics background, you can actually understand a lot of very complicated things. For example, I'm not sure how you learn about how to put the YOLO into practice, right? Then how you learn about the framework in OpenVINO, and also how you know the OpenPOS, because like I have my students that work on OpenPOS as well, and they also doing very similar thing, and they are like age of 20s and above. They are like second, third year of undergraduate. So I don't see there's much different than what you have done and compared to them, but you are actually much younger than them. So much younger, not just in the term of age, but also in term of education level, because you guys are still in high school, and there is actually a significant difference between what you learn in school and also in university. So over here, I would like to stress to all of you, the rest of the audience that watching this video, I really appreciate. And I think like you guys have done a great job to actually demonstrate that like the dreams that I once hoped to achieve, which is how to say, make learning and also make education regarding AIs and also robotics, especially for us, service robot is something that very complicated. So how we want to put all these things together to make something that's reachable for even people at the age of 15, something like, yeah, in school. So I guess this video will be very inspiring, I can say, for all the teams. I try to promote for the rest of the team to join this. So maybe I would like to share the screen to make people know you more. Okay, so let me share this. Right. Okay, so is it correct? Yeah. No. Are you okay? So now it's correct, right? So you actually see the screen and also myself and so on, right? Okay, so I'm not sure. Yeah. Okay. Right. So now is the Q&A time. So all right, so let me turn on my chat. Okay, so can I have anyone that in the audience that if you have anything you want to ask the team, I appreciate you can actually put down in the chat, and we can start. So the time, as I actually put a 10 minutes delay on the starting time, so we have about 20 minutes for Q&A actually, before we do the summary and so on. So welcome any of you in the list of participants. So I appreciate if you can like put out some question for the teams, anything that you want to ask, not just not limited or not constraints to the technical thing, but also how they actually learn and how they form the team and how they actually, yeah, everything. So you can ask anything. So I'm thinking the team, they are very generous enough to share this information in this session, because this session, they are going to like tell you all the secret how they can become the winner in our competition. So while waiting for the question from the audience, I would like to ask some question, right? So for the teams.
Okay.
So first is like, I can see like you guys are very self-organized, okay? Because like you mentioned, like you use the Notion thing, okay? I just got to know about this Notion thing. And then I also saw like you guys are actually do all the learning and development by yourself, right? Because I don't see actually much description or whatever that you say that actually related to your coaches. So because like I know your coaches, Mr. Thomas and Mr. Kinda. So can you also tell me that what are their roles, and also what the school actually provided in order for you to able to do such development?
So actually, the school has provided robots or other environment for us to test, and also so as I present, you think we have talked everything as we have done ourselves, but actually sometimes the teacher will have to help ourselves a little bit of it. So I just said that why I have divided the person forward into two nodes. So actually before I find out the solution, I've been panicked a lot before I find a solution for how to
get over the delay problem. So so my teacher has helped me out a little bit with his experiments, and then it can also help using his experience, and then I've done with these 2 notes for it. So also our coaches will always help us when we need help. It could always help us with some experiments from it. So our team can do a lot of things, but what we didn't have is experience. So actually, this is what our coaches need to have will help us because we have less experience of it. So Joshua will talk more about it.
So I'm just going to say just our school put a lot of like developments in like the research of development of robots or different technical competition, and so I mean we are just very blessed that we have the environment and also the machine we can use in our school to develop everything we have right now.
Okay, right, and so to say that, so which mean I believe, because like I visited your school before, like I was quite very surprised that with the environment that you have, the facilities that you have, and also the quality of the workflow that you already established in your school or in your lab, that you have a very nice environment that you can proceed with such technical development and so on. So I guess that is something that is how to say, not easy to have, and I believe that your coaches or your school, they have worked very hard to provide such facility and environment for you. And also, okay, so talking about not just the hardware things, do you find that okay, I believe, like just how you said, you search all the solution. For example, like you learn how to use YOLO, how to use OpenVINO, how to use OpenPose. Do you think that you can actually understand the materials that you have found online in order for you to learn everything? Because like some of maybe younger, I don't know, because like some teacher actually asked me like they have to really teach the children how to learn all this materials, especially like when want to implement in source code and also try to make it work. Right. So I would like to know like how you actually learn. Okay, maybe you can take example. For example, like before you know about YOLO and how you actually pick up YOLO and do the training of the, for example, like you collect all the images, you do the training, and up to you able to implement in your hardware. So the learning thing, of course, I understand the technical operation, but the learning thing means, so do you solely focus on learning from YouTube video, or you actually have books, or you search the material online or so on? So how you learn all this skill actually?
So actually on YOLO part, so I'm in charge of how to do YOLO. So after we get the YOLO from the technical section, we have searches for it for how it works, and then we have find the Python wrapper of YOLO for it. But actually, because YOLO is a very complicated algorithm for it is new and advanced, so our team can be. We can really truly understand YOLO's algorithm. So we have seek help for our coaches, but it seems like our coaches have some problem of helping. No problem. Sorry. But it seems like our coaches has also think that this is a little bit hard of understanding YOLO. So sorry. So we have YOLO we didn't is the algorithm that we didn't truly understand. So actually YOLO has Joseph Redman, which is the inventor of YOLO, has pre-trained YOLO with the COCO data set that I just said it have a lot of category. So we just use the YOLO model that we already have.
So
I see.
Yeah.
All right.
Maybe
Okay.
sometimes we just learn like sometime because our coaches will teach us, but like most important we might just watch some website or YouTube to learn the program.
Yeah, because I think totally understandable that you guys can't understand a lot of the theory, is because like you need a lot of background in order to understand. like for example, like when they come up with an equation that you don't really able to understand and don't have any background, is really very hard for you to understand. I understand that. So that's why I'm very amazed that you're able to actually run the algorithm and implement in your development. So that is something that I feel you guys have put a lot of hard work on making it works, because to understand something that you already don't understand a lot of the theory, to put it into practice and make your robot able to behave to the things that you want. Because I saw your video on the follower, right? Okay, so you try to like recognize someone, you use the OpenVINO framework to recognize and try to actually distinguish different persons. So that is something that I remember I assigned my student to do, and they actually not able to complete it very nicely. Yeah. So I can say like it is actually not so easy, but do you actually, how to say, like, how do you actually have a situation that, how to say, you find out, you found that you want to learn something, but you're not able to use it, or you're not able to understand, and you're not able to, I don't know, other than YOLO, OpenVINO, or OpenPost, do you actually try to explore other things that you don't understand as well?
So actually, I have in our school, except for RoboCup, we have a lot of other projects. Like myself, I have once done some projects which is research things about YOLO and other things.
Oh, okay, right.
So and also, the OpenVINO is a. I didn't do a lot of research on it. We didn't do a lot of research on it because we have because I just said that the version of the number of our follower is 2.2, which is very. We have just found YOLO in this March or April, so it is very close to our context. So that's why I didn't do a lot of research of it. But YOLO, I have to do a research of it. So also, besides YOLO, I have also researched a little bit about the face recognition system. So at first, we want to show the face recognition system at our live demo and also our video, but there's a little bit problem of it, so I didn't show a lot of it. So face recognition, I have to do a lot of research of it. So because this is the first project after I joined FatLab, this community here. So after I learned face recognition, I've done a lot of research on how it works and do with it. And also, this makes me learn how to use a lot of computer vision and other things. So, Joshua.
Okay, right. So I roughly get what you mean, but I think it is a solid proof that you guys have achieved something, right? So you have the result, and I actually can use you guys as a role model for me to tell, like, hey, actually, even high school actually can learn something, although we might not able to understand like fully because of the technical backgrounds that we still haven't reached. Like, I mean, like, you have still haven't reached certain fundamentals in order for you to understand all the theory parts, but you guys able to do something. So I think if, let's say, like, the research community able to make more, how to say, easy to understand materials to explain about all those complicated things, I think eventually we can actually empower more younger generation to actually pick up all these things, right? So I hope, like, after this, we also, like, me also part of it, that we as the research community on this field, we will try to generate more materials that you guys can understand and you guys can use it. I think this is something that a message that I would like to open for all the researchers and scientists out there, especially working on data science, AI, artificial intelligence, machine learning, and so on, so that we might want to think on how to actually make this material accessible for younger generation. So that's one thing. So the next question I would like to ask you is, like, before you join RoboCup at Home Education, and after you join RoboCup at Home Education, what do you think you have actually gained from your, how to say, involvement in these 2 years? For example, like, ever since, like, I went to your your school for the workshops, then I introduced this robot for you. I introduced the materials that you can learn. So where you start to do your speech recognition, you start to do your image recognition, and so on, and put them together to do service robot application. So before all these things happen, okay, then you compare to after you have this platform to learn this thing. So can you comment something on how much you actually gain after you join RoboCup at Home Education?
So for me, actually, I think the most thing that I gain is the programming knowledge, because actually most of this competition is like just about the raw system and also the programming. But I mean, I think that like I've gained is to just learn how to use different materials and to just sum up different technologies into to make a whole new project. So for example, we used like all we used the basis, and we used the microphone, we used the speaker, and we used the camera to just make a whole lot of different functions. So I just think that I've learned to just how to use different technologies to make up something that is very powerful.
Mm-hmm.
And also, our teammates will talk a little bit about it.
Yeah, and actually because I have like when I'm in school, I learn a lot of math and also physics, and I'm good at it. And then actually sometimes I don't know where to use the math and also where to use the physics, because like the calculus, we won't use the calculus to buy foods in supermarkets. So it's somehow, yeah, it's somehow useless for like in life. But finally, I have because of the RoboCup, this platform, I have an opportunity to use my knowledge and also my skill to like provide my skill out. Yeah.
So I'll talk a little bit. So, as you know, I'm only a secondary school student, so I'm very young right now. So I didn't have a lot of knowledge. So what I've learned here is I have learned how to gather these knowledges like YOLO, his physics or calculus and other projects to gather them up to make a new thing up, which is like a gathering thing to make this robot out with its functions and features with it. And also I've learned how to manage the project, and then how to calculate, how to manage the project, and also to how after we have created a new idea with a project, how can I manage it, and then also how can I create it, and also how I achieve it.
Yeah, so I guess like you have learned a lot like through this platform, through these activities, and you're still very young. I mean, like you guys are still very young, so you have a lot of opportunity, and I think now you have wider options and also ways to actually accumulate, or how to say, to find more new knowledge that you can self-learn, right? Because now a lot of things already online, so you can self-learn, you know where to find all these things, and you know how to learn them and to put together to create something more amazing. So I really wish you good luck, and I hope like whatever that you have achieved or whatever that you have gained in these activities will actually be very helpful in your education later, in your development later, and also in maybe in your life later. Like all this skill might be very useful somehow. I don't know. As you said, I really like that you say the fact that you actually learn how to put into practice or how to apply things that you learn in classroom in this activity. So that is actually very important for me as education. Not just we know the theory, or not just we know about what is it, but if we can implement or use it in some practical application, I think that is more important. For me, it's like I'm trained to be in engineering, so it's very important that we need to put things into practice and not just like the equation, but the equation means something that happen in the real world. So I think like I hope you can actually all this that you gain will be very useful after that, right? So once again, I think like we are also almost the time. So do you have any things you want to add? Any more things that you want to add as a final remark?
And so if
No, it's
Yeah, we are
okay.
good.
Yeah.
Okay, right. So thanks a lot, your team. Thanks, the Grey Area, and also thanks to both your coaches who are not here today. But thanks them for actually bringing you guys on this journey. And I talked to them a lot about how to actually let you able to do the development and also join this competition. So I thanks a lot for your great presentation. So I wish you good luck, and I would like to close this session. But before that, let me do a summary. Okay, so for the rest of you, we will put this video and also the materials. We will share the materials, and later on we'll put it on our website. So on the screen, you can see our website URL. And also, I would like to encourage you to like our Facebook page and also join our Facebook group in order for us to communicate. And also, more importantly, most of our activities will be announced over there. So we will have all the announcement over there. And also for our GitHub, I'm not sure like how much we can share the source code today, but we will try to put whatever things that we can share open source over there for you to learn how to build robots and also learn about AI, right? And our online classroom still running. Currently, we have a new series on online tutorial, but hopefully in near future, we can plan more online classroom in future, which is the live interactive format. But of course, the previous online classroom, all the videos and also all the materials like the slides and also the source code, they're all there over there. So you can head to our website to find all those things. And also for any of you, especially people that you are leading some of your community, yeah, feel free to contact us. You can write us an email. So over there, I will first read the email. So you can write to us and we can discuss how to actually make full use of the free resources, the open resources that we have here to actually empower your community, right? So as a last, so this one before we end, so just the last to promote. So after this, so today is the first one for this special online challenge 2020 invited lecture series. Then after that, next week we have our teams from Canada, and then later on we have from Malaysia, from China, from UK, and also from France. So we will run this thing. We try to make it like every week, but maybe some convenience time. So we put it in this way. But of course, like I also still try to discuss with some of the teams, and hopefully it can like put in between. But now from August until September, so we have this in the list, and I invite and also I welcome you to join. So I put the QR code there, so you can just scan it to the site, and then when the registration link is available, so when you can see like the time, everything is already fixed, you can actually register from there and join like today, right? Okay, so I guess that's all for today. So this is the last one. Okay, so yeah, we are about 4 minutes over our time. So thanks a lot. Thanks team, the Grey Area. I hope you will. I'm not sure. Have you received your prizes? But I think I saw your cert. So you already got your cert and so on. So I hope like uh, your work is fully recognized by us, by our community. And I hope you can continue this development, not only just our activities, but also you can spread whatever that you have learned for your other activities and also for your personal development as well. Right, thanks a lot. And thanks everyone. And I would like to stop here and thanks and hope to see you in our next online session, which is now should be on the next Monday, right? Okay, thanks a lot and see you.
Yeah.
Bye.
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 Thank you. Bye.
我留咗一陣，跟住就走。
其實呢流會聽到。